Okay, and we're working on chapter 13. So the question is, we have chords. So we have a circle to begin with. And we have two chords, chord AB and chord DC. These two chords intersect at point X. And we have to show that XA multiplied by XB is the same as XC multiplied by XD. Okay, so they're helping us with the steps. So we'll follow the steps that they're suggesting, and they're saying draw AD and BC, which we just did. Oh no, we didn't, sorry. Draw AD and BC, in other words, make two triangles. Okay, so here we have two triangles, and it says you have to prove, to explain why angle XDA, which is this angle over here, why would this angle be equal to angle XBC? XBC. Is anybody willing to explain why? So the question is why angle ADC is equal to angle XBC. Is anybody willing to participate and tell me, what do you think? Why are we saying that these two angles are equal? No? Again, guys, please don't be shy. Like, even if it's not right, we learn. So we'll correct you. No, okay, no problem. So tell me, please. We're talking about angle AD, they called it XDA. XDA. It's the same as angle CDA. Angle CDA is sitting on what arc? On arc AC, is that correct? So it's inscribed angle which is sitting on arc AC. At the same time, angle, okay, so I'll write it here so that I don't have to look at my other screen every time. So I'm trying to prove, as step one, I'm trying to prove that angle XDA is equal to angle XBC. And the proof is angle XDA, which is the same as angle CDA, is an inscribed angle which is sitting on arc AC. Okay, so angle XDA is sitting on arc AC. Okay, at the same time, angle XBC, which is the same as angle ABC, it's another inscribed circle, inscribed angle, which is sitting on which arc? I'll call it X. Sitting on the same exactly arc, AC. What does it tell us about these two angles? If there are two inscribed angles that are sitting on the same arc, what conclusion can we make about these angles? They're equal. So therefore, I hope you know that we can, in math, we use that symbol. Therefore is actually 3 dots. I'm sure you're familiar with that. But this is like, as a result, angle XDA is equal to angle XBC. Okay, so now we have two triangles. Let me just use colors I have here. We have two triangles. I have this small purple triangle XAD and another, I can use green possibly, and another green triangle XCB. So tell me, please, or I'll tell you if not, what can we say about these two triangles now? Are you guys familiar with two triangles being similar? How do we know if two triangles are similar? Nobody's willing to talk. Guys, what's like, why are you so shy? Anybody? No? Okay. Two triangles are similar if we know that three angles in one triangle are equal to three angles in another triangle. Then we say the two triangles are similar. And then if two triangles are similar, there are like special properties that we can use then to find the length of the sides or to prove something and so on. So my goal is now to prove that two triangles are similar. Which two triangles? That would be triangle XAD and triangle XBC. And the symbol for similarity is this symbol. That means similar. You can prove that they are similar from angle. Excellent, Jerry. Thank you so much. Right. So it's enough to have two angles, you're right. And then the third angle obviously is the third angles are equal by itself. Absolutely correct. So I already just proved that angle D in the purple triangle is equal to angle B in the green triangle. We just proved that. What else can we say? Which other two angles you can easily prove that they are equal, and for what reason? Is anybody willing to answer that? Because to have just one angle in each triangle is not enough. We need.
You can prove that AXD and CXB are similar because they're like, I don't know how to explain it, but like they're
opposite. You're absolutely
they're
right. Absolutely right. They're opposite angles, Jerry. So these two angles are opposite. Like if we have two intersecting lines here, there are four angles formed, and there are two pairs of opposite angles. If I label them 1, 2, 3, 4, then angle 1 and 3 are opposite and they're equal. Same as angle 2 and 4 are opposite and they're also equal. So Jerry was absolutely right by saying, if to make it shorter, if I can call this one angle x1, let's say, and this one is angle x2, so I can say that angle x2 is equal to angle x1. We can only, we can just call it angle x here and angle x there. As Jerry said, he used 3 letters for each angle, which is correct. Or to make it shorter, I just label it 1 and 2. So x1 and x2 are equal. Why? Because they are opposite angles. Opposite angles. Okay. Then we also said that angle D is equal to angle B. It was already proven above, from above. And if we know that two angles of one triangle are equal to two angles in another triangle, obviously two triangles are similar. Now, when you write the similarity, the two triangles are similar, the order is very important. You must write, the first triangle can be written in any order you want, nobody cares. But the second triangle has to follow the same order of letters. If I started here with letter X, then the second triangle has to start with letter X as well, because the angles X1 and X2 are equal. Then if I went with letter A, then I have to go with letter, let me see if I did it correctly, by the way, XAD. No, I didn't, by the way. This is not XBC, so that must be XCD. Hold on, just give me 1 second. XCB. Yep. I'll correct that. Please make corrections. XCB. The reason is we proved that angle D is equal to angle B, and these are my last 2 letters in each triangle. Therefore, in the middle, here I will have angle A, and here I will have angle C. So these two triangles are similar. So it was proven following AA, angle. Now, if we know that two triangles are similar, that means the ratio of the corresponding sides are equal. What does it mean, corresponding sides? You take side XA, let's say from the first triangle, is corresponding with side XC from the second triangle. So you can say that XA over XC is equal to, what would be the next pair that I will label then, or will mention then? Which two other sides are corresponding sides in these two triangles? Anybody is willing to help me?
XD and XB.
XD and XB. Yes, XD and XB. Yes, you're right. Okay, and the last one would be then what? whatever we have left, right? The third side, which will be AD over CB, correct? Okay. Our goal to begin with was to prove that XA times XB is the same as XC times XD. I have my XA with XC over here, and I have my XB with XD over here. So this is true, but I won't even need it. Now, if I have this ratio, this proportion that I have two equal ratios, when I cross multiply them, what will happen? I will have XA times XB is equal to XC times XD, right? Cross multiplying. And we proved exactly what they asked us to prove, that XA times XB is equal to XC times XD. That's it, it's proven. So we used a few things here. First of all, we used the fact that inscribed angles sitting on the same arc are equal. We used opposite angles, we used similarity of two triangles, and then from the similarity of two triangles, we were able to prove that whatever they asked us to prove. Anybody, any question? No? Okay, we'll move on to the next question then, which is problem 13.2. So I'll remove that. And then moving on to 13.2. Where here we have point P is outside a given circle and A is on the circle. Point A is on the circle such that PA is a tangent. Can anybody remind me, what does it mean, a tangent? Anybody knows what does it mean, a tangent? You think, and I'll meantime start the diagram. Okay, so this is a root diagram. So anybody, what is a tangent? A tangent is a line segment or a line which touches your circle at one point only, where chord is a line segment or line which crosses your circle in 2 points. Okay, so on the diagram here, PA is a tangent. P is a point somewhere outside of the circle. A is a point on a circle, and this PA is just touching your circle at one point. So therefore, PA is a tangent. Where BC is, or PC is a chord, actually, BC is a chord. Okay, so what do we have here? Point P is outside of the given circle, and A is the circle, is on the circle such that PA is a tangent. C and E are on the circle such that secants PC and PE intersect the circle again at point B and point D. So PC is a secant, PE is a secant. Secant means that it's a line or line segment which crosses your circle at 2 points. Okay, BC is a chord, PC is a secant. Same as DE is another chord, PE is a secant. What we have to prove though is that PA squared is equal to PB times PC, and it's the same as PD times PE. Okay, so this is what we're trying to prove. Hold on, let me just move that a little bit away. Yeah, okay. Okay, so everybody understands the question? So we have a tangent, then we have two secants that they intersect with the circle at points B and D, and we have to prove that PA squared, the length of the tangent squared, will be the same as PB times PC, or the same as PD times PE. Okay, So the steps, so they're saying draw AB. So they're suggesting we connect A with B and A with C. I'm going to connect A with B and A with C. Okay. And then the question is, we have to prove why angle ACP, which is this angle here, why is this angle equal to angle BAP, to this angle? Okay, so this is what we are trying to prove. That's the first step. Any idea, any suggestion? What do we do here? So again, we're trying to prove that this angle is equal to angle ACB is equal to angle PAB. So first step, angle ACP is equal to angle BAP. Anybody, any suggestion, any idea? Let's think what this angle PAB is. What kind of angle is that? Between what and what? I'll give you a minute, guys, to think about it. Anybody? This angle ACB, it's sitting on which arc? Angle ACB. ACB, sitting, or it's an inscribed circle, sorry, inscribed angle, and it's sitting on arc AB. Do we understand that? Therefore, it should be equal to half of that arc, right? In degrees. So we can say that angle ACB is equal to half of the arc AB. Is everybody okay with that? What about angle PAB? That's the angle between which two lines? Remember, PA is a tangent, AB is a chord. So the angle formed between a tangent and a chord will be also equal to half of the arc, which is cut by that chord, and the arc is AB. So that means that angle PAB will be equal to half of exactly same arc AB. Okay, do I understand that part? This is all from, guys, from chapter 12. These ideas from chapter 12. If you remember it, I hope you covered it. You're not saying anything, so it's hard for me to decide whether you did or didn't. So I would assume that you did. Once again, so the inscribed circle, inscribed angle is always equal to half of the arc that it's sitting on. So that's why angle ACB is equal to half of the arc AB. The angle between the tangent and the chord is also equal to half of the arc that the chord is cutting from the circle, which will be half of the same arc. So that seems now that these two angles are equal to half of the same chord, which means they're equal to each other. So now we proved that angle ACB is equal to angle BAP. How does that help? Next thing we want to do is to prove, we're probably going into some similarity of the triangles again. We have two similar triangles here. So we already proved that this angle in the triangle ABC is equal to this angle in the triangle PAB. At the same time, instead of considering triangle ACB, we can consider triangle PCA, the whole thing. Can we prove that the large triangle PCA and a smaller triangle PAB are similar? How can we prove that? Let's see, what do we have for that? So we're considering two triangles, guys. One of them will be triangle PAB. The other one will be triangle PCA. Let's see if we can prove that these two triangles are similar. Do we have enough information to say that? What do you think? Like in the previous question, like Jerry said, to prove the two triangles are similar, it's enough to prove, to show that we have two angles in one triangle that are equal to two angles in another triangle. Do we already just proved, did we just prove that two, like one angle in one triangle is equal to one angle in another triangle, this A and C? A is the angle in triangle PAB. Maybe I'll use colors for the triangles. Maybe that will make it easier. So if I look at PAB, okay, that's one triangle. And another triangle will be this one. Okay, in the pink triangle and the green triangle, if we call them, just to make it shorter. What do you see here? Anybody seeing something else in addition to the fact that we already proved that angle A is equal to angle C? Anybody, guys? Guys, what about angle P? It belongs to triangle PAC, and it also belongs to triangle PAB. But because it belongs to both triangles, we call it a common angle, and then obviously it's the same angle. So we do have two angles in one triangle are equal to two angles in another triangle. That makes these two triangles similar. So we can say that triangle PAB is similar to triangle PCA. We did it based on AA. One angle was proven right here. And another angle, angle P, is a common angle, right? So angle P is equal to angle P. It's a common angle. Okay? And that makes two triangles similar. If these two triangles are similar, what ratios I can write here? I can say that PA over what? Guys, please be a little bit more active. I know it's a little late at night already, but please. And don't be shy. No? Okay. So we take the first two letters from the first triangle over the first two letters from the second triangle. So PA over PC is the same as. We'll take the first two letters, sorry, the last two letters from the first triangle, which is AB, over the last two letters from the second triangle, which is AC or CA. And it's the same as, we take the first and the last letters, PB, over the first and the last, which is PA. Okay. Now, my goal is to prove this, remember? PA squared. How would I get PA squared? If I take this one with this one and cross multiply, what will happen? Because when I have two equal ratios, I can cross multiply them and I should get equal expressions, right? So I go PA times another PA. Can I say it's PA squared? Equals, I take the bottom of the first times the top of the second, PC times PB. So far, so good. We proved this part. You see, PA squared equals PB times PC. Now, the last thing to prove that it also equals to PD times PE. Did I copy it correctly? Yeah. PD. Wait a second. I was proving these two triangles. Just give me one more second. It's PD that we need. We proved that PAB is similar to PCA. Yes, we did. Okay. Now, we have to prove okay. So we have secant PC PD over PE, PD over PE. Oh yeah, we already proved before, if you remember, in the previous question. Just give me 1 second. There is nothing, okay. There is nothing special about secant PC, was nothing given special about it. What can we say then? So let me see. So we have PA over PB, PC, and PA. Yeah, we do have that. And that makes this. So this is proven. This is good. Now, PD times PE is equal to PA squared. Yeah, so if we do the same thing now with another side, we'll prove that PD times PE, PD times PE will be equal to PA squared. And then we can say, we already know PA squared is equal to that. Therefore, we can say that all three of them are equal. Right? So from here, we can now conclude that that will be the same as PD times PE. And that proves it all.
What does the symbol between like the triangle PAB and the triangle PCA?
Oh, similar. This one?
Yeah.
Yeah, that means similar.
Okay, thanks.
This means similar. By the way, I don't know if you know, I'm sure you talked about it, but if you have this same symbol with the equal sign underneath, that means congruent. That means congruent. Not right now, we don't have congruent triangles right now, but I'm just saying in the future, if you see that symbol, that means congruent. And congruent, that means that the two triangles have exactly same size and the same shape, right? Similar means that they're just the same shape, but not the same size. But congruent means that it's exactly identical. Okay, so yeah, that means similar. Thank you for asking. Okay, any questions so far? No. Okay, I guess we'll move on to the next question then. Let's see, that was 13.2. Let's see, what do we have in the next question? 13.3. Okay, I will remove that, guys. And I am on question 13.3. And we have two chords, TY and OP, meet at point K, such that, so okay, we have a circle again. We have two chords, TY and OP. TY and OP. Okay, this time they didn't give a diagram, so we'll make our own diagram. They meet at point K. That point is point K, such that TK, this part, TK is equal to 2. KY is equal to 16. Definitely not on my diagram. I will redo it then. After I label it, I'll redo it so it makes a little bit more realistic. and Kp equals to 2Ko. We have to find the length of OP. This is Ko, yeah, okay. I guess I will redo the diagram because if I call this 2, it doesn't make sense that unless I change the letters. If I call this is T, yeah, let's do that. If I call this is T and this is Y, that's more realistic now. So then this is 2 and this is 16, right? That makes more sense now. So TK is 2, KY is 16, KP, which is this, equals to 2KO, and we have to find the length of OP. Okay. Now KP is equal to 2KO. If I call this one X, can I say that this is, no, the other way around. You know what, I'll still redo the diagram because KP should be twice KO and it doesn't look like that and it might confuse you. So how about that? Here, I'll just make a new diagram. And I know that this must be 16. So if point K is here, this is still T and this is Y. This is 16 and this is 2. And then this KP, this is P, and this is O. So if I call this one X, can I call this one 2X because it's twice as long? Do I understand that? Okay, so that's it. So all we know, this is 16, this is 2, this is twice this, and we have to find the length of OP, the whole thing. Okay, as soon as we find 1X, for example, we know OP consists of 3 X's. But we have to find what 1X is. Okay, so let's see what we can do here. So maybe before we continue even, we will look at power of a point, which is a very useful conclusion that they're offering to us, useful property, and that will definitely help us to answer that question. So what they're saying is, suppose, I'll leave that for a few minutes, we'll come back here and we'll just talk about the power of a point theorem, it's called. Suppose that a line through a point P intersects a circle in 2 points, U and V. So the theorem states that for all such lines, the product of, okay, so PU, so if we have a circle and we have a line through point P intersects a circle in 2 points U and V. So if we have a line through point P that intersects at our circle at 2 points U and V, we can say that the product of PU by PV is constant. So it will be the same. We call this product the power of point P. Okay, so this product is called the power of point P. For example, if we have this kind of diagram, that's a circle, and then we have 2 chords intersecting like we have in our question that we consider we're looking at now. So if this is A, B, and this is D, C, and this point is point X. So what will happen is XA, so starting from XA multiplied by XB will be the same as XC times by XD. Okay, that's a very powerful, I would say, sentence and very helpful. Okay. That will exactly help us with our question now, that when we come back to that. But before we can come back to that question, we want also to consider the fact that we said the product of, if we have a diagram like from the previous question, there is a point outside and it's a tangent. PA is a tangent. This is B and this is C. That's a secant. And PDE, PE is another secant. What happens apparently is that PA squared, which we proved already in the previous question, PA squared is equal to PB times PC. PB times PC. And at the same time equals then to PD times PE. Okay, so these are the two important things for you to know and to be able to use. Okay, so this is called power of point theorem. Power of point theorem. Okay, so I hope guys you're taking notes. If not, I probably it's being recorded right now, so probably it will be available for you to watch later if you need, but this is important for you to know. So now, using that fact, if we're coming back here, how can I apply this power of a point theorem in my case here? What can I say? Using this, look at that. This is exactly what we have here, right? We're saying that XA times XB. Oh, sorry, you can't see what I'm showing. Over here, it says XA times XB will be the same as XC times XD. If so, how can I apply it here? What equation I can set up now? Can anybody help me? No? Okay, I feel a little lonely tonight, guys. I'm talking and not many of you are participating, but hopefully we'll establish a better relationship, and hopefully you will trust me more, and will be able to answer my questions. By the way, guys, just if you're interested, I am a teacher for, I don't know if you are all from Toronto or not, but I'm from Toronto, and I'm a teacher for Toronto District School Board, a high school teacher, and I teach for Toronto District School Board for the last 25 years, more than 25 years already, okay? So this year I'm teaching grade 9s and 10s. So just for your information, if you're interested to know. In any case, we'll go back here, and using that property, we can say that KY times KT will be the same as KP times KO. Can we say that? Does that make sense to you guys? You tell me. I forgot, you're not telling me anything, unfortunately. You're just listening to me very nicely and quietly. You're good listeners, guys. Not the best participants, but very good listeners, I have to say. Okay, so just give me 1 second. I'll move my screen here. Yeah, so what's KY? How much is KY? We know how much is KY, right? KY is 2. KT, 16, right? Equals KP times KO. We called KO, we called it X just to make it simpler. And KP is 2X. So it's 2X times another X. What does it make? So 2 times 16 is 32, equals 2X times X makes it 2X squared. Then what? Simple equation, guys. Divide both sides by 2. x squared equals 16. Therefore, x equals square root of 16, which is 4, right? Everybody's following it? So now if x is 4, then 2x is 8. And then the whole length of OP is 4 plus 8, or 3x. So it's 12, no? I don't remember if it was in centimeters or without units. Without units. So then OP will be 12. And where then? Questions? No questions? Okay. We'll move on to question 13.4. Yeah, so here we go. I'm removing that. 13.4. What do we have there? Okay, so in the diagram, so this time we do have a diagram. So we have a circle. We have two secants. This is A, this is B, this is C. So we have a secant AC and a secant EC. Okay. In the diagram, what we know is CB is 9, CB is 9, BA is 11, CE is 18, the whole thing CE is 18. We have to find DE. Okay. So how about that? If DE is something that I need to find, that would be X, right? If the whole thing CE was 18, how would I call DC in terms of X then? If I said ED is X, CE is 18. Can you give me an expression for DC, please? No, that would be 18 minus X. Is that clear? Because it's the whole thing minus X. Because the whole thing was X. So that's it. We have to find X. So what can we say? Do you see that point C is outside of the circle? So we can say that 9, like in other words, this CB times whole thing, which is AC, should it be the same as CD times CE? Is that fair to say? Is that correct?
Yeah.
Yeah, okay, you agree with that? That's based again on the power of point theorem that we just discussed. Okay, let's substitute in whatever we know. CB is 9 times AC. How much is AC?
18. I mean, the 20.
20, right, thank you. Equals, on another side, CD. How do we call CD? 18 minus X, right? So it will be 18 minus X times CE. And the whole CE is how much?
18.
18, thank you. Is it Songyang? Thank you, Songyang. Okay, so now can we simplify the left side, the right side, whatever we can do. So 9 times 20 will make it 180 equals. We can, I'm not going to even expand the brackets, to be honest with you. Look, if I keep it 18 minus X multiplied by 18, I can of course expand the brackets, but I won't. Too lazy to figure out now 18 times 18. How about right away, I will divide this side by 18. and this side by 18. That will make it 18 minus x on this side, and I get 10 on the left side. Is that correct? And from here, what is x? X equals 8. Is that correct? Then ED equals 8, because we did call ED x, and we found that x is 8. So that answers our question. Let me just double check. Yeah. Yeah. Okay. That was quite simple, right? Okay. So we're good there. We'll move on to, unless you have questions.
How did you get the CB times AC equals CD times CE?
Oh, okay. This is back from the power of a point theorem, where they say if you have a point outside of the triangle and you make a secant from that point to your triangle, to your circle, sorry, apparently, like your secant will obviously intersect with your circle in 2 points. That's why it's called a secant. The product of the distance from that point to the first point of intersection by the whole secant is constant. So now if I have another secant here, call it KF, let's say, right? Then PK times PF will be the same, like that PU times PV will be equal to PK times PF. That's what this power of point theorem is telling you. And I used that here. I said, okay, this is one point C. From that point, I have 2 secants coming from the same point. One of them is secant CA, another one is secant CE. So for secant CA, I can say that CB times the whole secant, which is CA, that's why I said that, or AC, is the same as CD times CE, CD times CE. And then I just substituted whatever I was given. So this came directly from the power of a point theorem. Okay? Does that answer your question?
Yeah.
Perfect. Thank you. Thank you for asking. I'm on the next question, 13.5. Hopefully we'll be able to get through. So the question is, you know what, first I'll make a diagram, I guess, because this time they gave us a diagram. So I'll make a diagram and then I'll read the information and I'll label whatever I have. So again, we have a circle. Okay. Then we have a point P outside of a circle. Sorry, guys. Point P outside of a circle, which creates one secant PS. This is R. This is S. Then we have another secant from the same point. This is point U. And this is point Q. Then there is a chord QT. And this point is point M. I'm just copying the diagram for now, then we'll read all the information and we'll label it. So, okay, points R and M, these 2 points, trisect PS. Trisect means divide into 3 equal parts. To bisect means to divide into 2 equal parts. To trisect means to divide into 3 equal parts. So in other words, PR, this, is the same as RM, and it's the same as MS, okay? So these 3 line segments are equal. Point U is the midpoint of PQ. Point U, this point, is a midpoint of PQ, not so much on my diagram, but I'm not going to fix it. I can say that this is the same as this. Midpoint means divides into 2 equal parts, same as to bisect. Okay, what else? TM equals 2. TM, this part, equals 2. MQ equals 8. MQ equals 8. This is 8. And first we have to find RM. So A, find RM and MS. That's question A. And then we have question B, but we'll talk about it later if we have time. So we have to find the length of RM and MS. First of all, what do we know about RM and MS? What do we know about them? Anybody? Are they equal? No? Anything? Am I right? Am I wrong? They're equal, right? RM and MS, they are equal. So just give me 1 second here. I'm checking something. This point M is the power of a point theorem again. It's the same as I'll bring it back here. This. What did we say here? We said that XA times XB is the same as XC times XD. This point M is exactly the power of a point. So what can we say based on that? We can say that MT multiplied by MQ, what would it be equal to? Can anybody help me? Guys, if point M is the power of a point, then MT times MQ should be equal to MS times MR, no? Right? MS times MR. Now, MT is given. MT is 2. MQ is given. It is 8. Must be equal to MS times MR. But aren't they equal? MS and MR, remember they said that these 2 points trisect PS. Therefore, we said this PR is the same as RM and the same as MS. So when I say MS times MR, it's the same as MS squared or MR squared, same thing. Can we solve now for MS? 2 times 8 is 16 equals MS squared. Therefore, MS would be equal to 4. And the same with RM, right? So RM equals MS and equals to 4. Do you understand that? Okay. Now, that's all they wanted in A, I believe. Yeah. Now, what else did they want? Check what was question B. I didn't write that down. So let's see. Oh, I went too far. Jumped too far right there. Just give me 1 minute, guys. I have to bring that page back. Just jumped right away. Coming. Another minute, half a minute, I will be there. Okay, so it was question 13.5. Here we go. Yeah. Again. 13.5. Okay. So for question B, they wanted us to use the relationship you found in problem 13.2 to find PU. So we have to find the length of PU. By the way, PU in this case is the same as UQ, they told us, right? Yeah. So we have to find the length of PU. And they're suggesting we use the knowledge that we got from the 13.2. And in 13.2, we said that the whole secant squared will be equal to PU times UQ. So what can we say then? Let's see. Okay, so we are saying that yeah, we finished with that part. We found that MR is 4. That's fine. Now we can say that PS, the whole thing PS, is equal to 3MR. Right. And that's 12, right? If so PS will be equal to 4 times 3, right? Each piece is 4 times 3 will make it 12. So PS is 12. At the same time, PQ equals to 2 PU, right? Yeah. Okay. Now we can say that PU times PQ, so PU times PQ will be the same as PR times PS. PR times PS. Okay, so now let's see. PU, if I call it X just to make it simpler, then PU will be X, PQ will be 2X, right? Because it equals to 2 of PU. So that will be the same as PR, which is 4 times PS, which is 12. Do I understand that? Now we're getting, this is X times 2X will make it 2X squared equals 4 times 12, which is 48. So far, so good. Now we divide both sides by 2. We get X squared equals 24. And now to get X itself, we square root it. So X will be equal to square root of 24. But we never leave under the square root something that one of the factors is a perfect square. How can we factor 24 that one of the factors is a perfect square that can be taken out of the square root? Remember your perfect squares?
4 and 6.
Thank you. So X will be the same as 4 times 6. 4 is a perfect square. Square root of 4 is 2. So you are getting 2 square root of 6. So 2 radical 6. And that would be the length of X. And X was PU. And I believe they wanted PU.